Okay. All right. Section 6.3.
Okay. So the last, like, I'm going to say 4 or 5 questions were solve the equation. And the specific one that I struggled with, frankly, I got it right on the homework because I just guessed correctly. It was 16 to the x plus 1 power equals 2/4 to the x minus 1 power. The other ones I figured out. This one I could not.
Like that?
Yeah, exactly like that.
Okay. All right. So the first thing to do is to write 2/4 as 1/2.
Yeah.
And then your common base is 2, because 1/2 is 2 to the negative 1.
That's where I messed it up.
And 16 is 2 to the 4th.
Okay.
And I know you know this, but I'm going to talk about it just so it's in the recording. When you raise a power to a power, you multiply the exponent. So you need to multiply 4 times x plus 1. And on this side, you need to multiply negative 1 times x plus 1. And now that the bases are the same, you can make the exponents equal and solve that equation. So I'll add x and subtract 1 and divide by 5.
Okay. I messed up the negative 1.
This is the key right there.
Yeah, that's where I screwed up. That actually makes sense, though. Thank you.
All right. Is that the only one?
Could you show us how to do just a simple one, but it was 8x equals 1. And that one, for whatever reason, just tripped me up.
That requires that you remember the rule that anything to the 0 power is equal to 1.
Yes, you are so right.
Therefore, x is 0.
That's why it trips me up. Okay. Yep. Now I get it.
Well, is it just going to be me and you tonight? Maybe a short session.
I'm
here.
Oh, Travis is here. Okay, I didn't see you. Why is... Okay, my screen's doing funny things. It's only showing me who's talking at the moment, I guess. So, who do we have with us? Travis and Sarah. Who else is here?
Tish.
Okay. Anybody else? Alright, let me see. Why is it...
Miss Wendel, when you screen to the right, where you one that's talking all the time, the small action video.
Yeah.
You see the 3 little buttons in the left top corner of that screen?
No, mine doesn't have 3 little buttons.
Okay. Well, just above the video on mine, it's got option to minimize, show small active speaker, and show thumbnails. Thumbnails will show you everything. Well, limited. You might have to point at it with your mouse.
All right. All right, I don't know, but as long, excuse me, as long as I know who's here, that's okay. All right, Travis, do you have a question?
I don't, Miss Wendel. I haven't had a chance to get that far with it.
Okay.
You know, been able to do so far what I have done.
Okay.
But looking at what you just did right there, I'm probably going to have.
Tish, do you have a question?
I do. On the video on 85, the problem 85, I was really confused why you get 4x equals 7, and then how to go from there.
All right, what was the original question?
It's 4 to the power of x equals 7.
That one had the it was if 4 is it had more to it, Tish. Do you remember?
Did it?
Yeah,
Okay.
it had it had if 4 is negative 2x.
Oh, that's
Yeah.
what I wrote down. Okay. I thought I wrote it all down. Okay.
All right, wait. I'm still not understanding. This is one that I put on the video.
Yes, it was the last problem you did, and it was 4x equals 7. So if 4 is to the negative 2x, what would 7 be?
All right, hang on. Let me get over there where we were.
It's so confusing.
Yeah, I was all like, how did she get this from that? And why does 7 come into play? What?
Okay, hang on. I'm almost there. Oh, okay. If 4 to the x equals 7, what does 4 to the negative 2x equal? Okay, all right, I'm with you. So the question is, what can we do to this to make it equal this? And it requires that you remember that that what causes you to multiply exponents is when you raise a power to a power. That's what causes you to multiply exponents.
Okay.
So to get this to be multiplied by negative 2, it means we raised it to the negative 2 power.
Okay.
So if we raise this side to the negative 2 power, we have to raise this side to the negative 2 power. And the question then is, what does this equal? Well, that requires that you remember that if you have a negative exponent, it's 1 over with the positive exponent. So 7 to the negative 2 is 1 over 7 to the positive 2. And I hope I put 1 over 49 as the answer.
You did.
Okay.
I was just real confused how you got to that point.
Yeah.
Okay. I just finished watching the video, so I'm finishing the rest of it tonight.
Okay.
Yeah.
All right. Has anybody else joined us?
I don't think so.
Okay. All right. Let me remind y'all of 2 things that's going to become really important in section 6.4. When we studied radicals and exponents, excuse me, I can't get that frog out of my throat. We talked about P over R. That when you have a fractional exponent, the R becomes the root, and the P is the power that you raise A to. So, if you have 17 to the 2/3 power, that's the cube root of 17 squared. And the place that comes into play most often is the square root, going back this direction. If you have the square root of something, since this is an understood 2 and this is an understood 1, that would be 12 to the 1/2 power. And in section 6.4, there are a couple of cases where you have to go from radical back to an exponent. So you're going to need to keep this rule in mind. The other rule you're going to need is that one that we were just talking about, that a negative exponent becomes 1 over that. So for example, if I had 1 over 10, that's 10 to the negative 1. If I had 1 over 25, it would be 25 to the negative 1, but it could also be 5 to the negative 2. Because 25 is 5 squared. So those are two pieces of the puzzle that are things from the past that I wanted to remind you about to help you with 6.4. All right.
Okay.
Anybody have any other kinds of questions that I can help you with?
No. No, that was my only question. That
Okay.
one question I asked you was.
Okay, so Amanda's with us?
Yes.
Okay. I lost my paper. There it is. So right now I have Travis, Sarah, Tish, and Amanda. Is that true? Is there anybody else with us?
No.
Okay. All right. I don't know. Does it help if I talk about something that's coming up, or does that confuse you when you have to go back and do the old work?
Doesn't help me, but I don't want to answer for the whole group.
Okay. Well,
I feel like it's nice to know what you're looking forward to.
okay.
But,
All right.
it's,
I'm gonna talk about it because unless y'all took Algebra 2 in high school, you've probably never encountered logarithms. And what brings us into logarithms, an exponential function is a number raised to a power, x. Well, to do the inverse of that, then x needs to be the exponent that goes with 3 to give you y for the answer. Well, there's no way mathematically to write that. If you want to solve for x, it's the exponent that goes with 3 to give you y for the answer. And so the way they wrote it is that x is the exponent. So a logarithm is an exponent that goes with 3 to give... Hold on, I got to figure out how to make my phone hush. There, sorry. I thought I had it turned down. X is the exponent that goes with 3 to give you y for the answer. And on the handout that I sent, thank you, Sarah, for reminding me that I had never sent it, it has this in generic letter form. But this is called exponential form, and this is called log form. And so a lot of the questions are changing from one form to the other. So I thought it might be good for us to just do a little practice with that part. For example, suppose you have 5 to the second equals 25. Well, clearly that's written in exponent form because it's got an exponent. So to change that to log form, whatever is the base of the exponent becomes the base of the logarithm. And since a log is an exponent, whatever it equals has to be the exponent. So you've got one spot left and one number left, so you put 25 here. And that's how you change from exponential form to log form. And what this, you read this, the log base 5 of 25 is equal to 2. And this 5 is written below the line. It's not on the line. But when you're doing the homework, there is a thing in the toolbox that lets you put a number down here, just like there is that lets you put a number as an exponent. So you'll have to click on that, because that 5 has to be what they call a subscript. It's actually kind of written below the line. Alright, another one, and you don't even have to be able to know what the answer is. Suppose I have 2 to the x equals 7.2. Well, I don't know what exponent goes with 2 to give you 7.2, and you don't either. Now, there is a way to use logarithms to find it out, but we're not going to do that part. We're not going to get that far. But we are going to talk about how you change this to log form. So you write the log, and if the base is the base, what it equals has to be the exponent, and so the 7.2 would go right there. Now, when it's already written in log form, then it's a little bit easier to change it. Well, it's not any easier. It's the same process, but there's a little, I don't know. I'll show you. The log base 3 of 1/9 equals -2. So here's a log statement. And the directions would be to change it to an exponential. Watch me. If you start here, swirl here, back to here. 3 to the -2 equals 1/9. Now, it's the same thing. Whatever's the base of the log is going to be the base of the exponential. Whatever the log was equal to, that's going to be an exponent, because a logarithm is an exponent. And you've got one number left and one spot left. But that, look, I call it the wave when I teach it in high school. You got to do the wave to get from log form to exponential form. And that helps you check when you've gone from exponential to log, do the wave and make sure it's what that is. 5 to the second equals 25. So you can do both of them, one as a check and one as a way to get the answer. Then there's some questions where you actually solve it. And when you're going to solve a log equation, the first thing you do is write it in exponential form. So we'll do 5 to the third equals x. And then you just do whatever's needed to solve for x. In this case, you just need to raise 5 to the third power. And you're good. Sometimes it's a little more complicated than that. Do the wave again. 3 to the second equals this mess. Well, you know 3 to the second is 9. Now you just say, what do I need to do to solve this equation? So you're going to add 2 and divide by 3, and you're through. So I really just taught y'all all of section 6.4. Y'all don't have to watch the video now. Go ahead, Travis.
Looks easy enough.
It is. This is a pretty easy section. Logarithms can get very, very complicated, but we don't have the time to get into that part. So I just wanted to introduce it to you so that if you ever see LOG written, you would at least know what it was and where it came from. The other thing that's going to be in this section, you know how if we write the square root of 14, we don't write the 2, but it's understood. Well, in the same kind of way, if I write the log of 5 and I don't put a base, it's understood to be 10. It's called common logarithms. And E, I told you about E in the video, I think, for 6.3. E is an irrational number. It's named after a man. He spells his name like this, but it's pronounced Euler, and that's where the E comes from. And it occurs a lot in natural phenomena, and it's used as the base of the natural logarithm. So it's used so much that instead of log base E, they write ln for natural logarithm. So if you see ln 8, it means log base E of 8. So this is called natural logarithms. This is called common logarithms. And you have to use those 2 pieces of information to do some of the problems. For example, let's do one. Suppose you have this. Well, you know that we want to write it in exponential form, so the first thing I would do is to show myself that ln means log base E. Then I would do the wave that e to the 8th equals this, which is e to the negative 2x. The bases are both e, so all you have to do is make the exponents equal, and then ask, what do I need to do to solve for x? Divide by negative 2, and the answer is negative 4. Alright, anybody got anything we can talk about? Y'all talk about the weather? Y'all talk about going back to school? We do need to talk about registration. Have y'all connected with somebody to do registration for next fall?
No.
Okay. Have y'all read my email that I sent you about doing registration?
Yes. Yes.
Okay. Alright, Miss Chapman really wants to help y'all get registered, and she said, and I think that's in the email as well, you don't have to pay money right now, but getting y'all registered is what allows her to set up the classes for the ones that are going to be face-to-face classes. So it's important for y'all. And the good news for y'all is you're through with math now. So she will help you. If you don't know, she will help you figure out what avenue you need to travel now that you're through with math. What else do I need to tell you? Oh, the final. Okay, this week the homework is going to be 6.4 and a review for the final. And I'm going to tell you that this is optional. Okay? If you think you're ready for the final without doing this review, that's fine. I won't penalize you if you don't want to do that. I think most of you need to do it, but that's your choice. And then the next week will be the final. And I had first said that I was going to only open it up on Monday. But I have to keep in mind that some of you have children running around and you have other issues going on, and so there might not be a 3-hour block on Monday where you can sit down to do the final. So I'm going to open it up from Monday to Wednesday, and I'll open it at 12 a.m., which is 12 in the morning on Monday, so essentially Sunday night. And I'm going to close it at 12 a.m. on Wednesday, which is Wednesday night. So you've got that block of time. But here's the deal, and this doesn't apply to y'all, but maybe the the people that it does apply to might listen to the video, there will not be any extensions. The other thing I want y'all to know is that I am going to open up all assignments that you've had up to this point. So if there's some that you didn't make 100 on and you want to go back and clear that up, you'll have that opportunity. It'll also give you the opportunity to go back to some of them for review purposes if you need to. So maybe I should have just put that in writing and not on the video so the people that aren't with us wouldn't know that. But anyway, they're probably not going to listen to this video anyway.
Is there any chance we can take a quiz for a third time?
No.
To put a bracket instead of a parenthesis?
I saw that on yours.
That haunted me. I lost sleep over that.
Sarah, your average might have to be a 99.9 instead of 100, but
that was very frustrating.
maybe you can live with that one. Anything else?
How much is the final worth of
It's
our grade?
30% of your grade.
Okay.
The midterm's 30%. The final's 30%. Midterm, final. Then you have homework and you have quizzes. This must be 20 and 20.
Mm-hmm.
Or maybe it's 25 and 15. I can't remember.
That's 2020.
Is it 2020? Well, there you go. All right. We still got 4 minutes. Anybody got anything you want to ask me? No, everybody's good?
I don't really know what to say.
Okay. Well, just like I always tell you, I'm retired and I'm sitting at home waiting on y'all to call me. So call me and ask me your questions. I have nowhere to go and nothing to do. I'm old and fat and they don't let me out of the house. So call me.
It's terrible. All right. Thank you, Miss Wendy.
All right.
Thank you.
Thank you.
Well, I hate that I can't see y'all in person, but that's the way life is, I guess. I wish there was going to be another class because I've enjoyed this group of people, and I wish this wasn't coming to an end, but it is. Life moves on.
I'll see you on Monday.
I will not.
That's on Mondays.
I'm done with in-person classes, but you were a fantastic professor, probably one of my favorites, so thank you so much for everything you did for us.
Well, you're welcome. Did y'all get a thing through your email about doing a survey?
Yes, ma'am.
Yes.
All right. Y'all be sure and fill that survey out, because typically, I mean, I trust you four. You four are going to be pretty decent ratings. Typically, who fills it out are the person that doesn't like me. And so if only one person fills it out and they're the person that thought I was a really bad teacher, then it looks bad. So I need a few of y'all that might say something positive to do it as well.
Yes, ma'am.
Well, I definitely think that you have been great, went above and beyond, and you helped tremendously. And I'll be happy to do that.
Well, I don't want you to say false things, because if there's something that I could have done differently that would have made it better, I would like for y'all to write that as well, because I always believe there's always room for improvement. But
you have said that all along, and you have given us all the opportunity to suggest everything. And I think you pretty much hit that right on the head.
Well, hopefully you'll never have to teach like this again.
Well, that's true. But think back to the in-class times as well. You know, if there was something in the in-class times that could have made things different, respond to that as well. Because there's a section on there that gives you opportunity for free, whatever, free comments or something.
Okay.
All right. Well, I guess we'll close out and say bye. Y'all call me if you need me.
Okay, thank you.
All right. Bye-bye.